Hey, A and Peers, this is Dr. Jones checking in. This is ANP1 Lecture Test 2, Video 11. And we are covering page 17 on this video, trying to keep the videos short so that they don't overwhelm my poor old computer, which is, more than 2 years old. So apparently that's old for a computer now. All right. So let's talk about, I did want to make sure that I had shown y'all this picture, that the pattern of the epidermal ridges is what makes your fingerprints. So, and everyone does have different fingerprints. Even identical twins that have identical DNA have different fingerprints. So, whoops, back. Okay. So, skin color. There are two pigments in the epidermis. Let's go red. Red works well on the white. Let's talk about melanin first, and we'll come back and talk about keratin. Melanin and keratin are the two pigments. Melanin is a red-yellow or brown-black pigment called melanin, and it's produced by melanocytes. Melanocytes are located in the stratum basale, which is also called the stratum germinativum. It's technically kind of between the stratum basale and the basement membrane, which is also called the basal lamina. Excellent. So the melanin is packaged into little bubbles, membrane-bound bubbles called melanosomes. And you may recall some means body. If not, learn that soma. You'll see the word soma a lot this semester and next semester. So it just means body. So it's a little bubble, a little body of melanin. So the melanosomes are the little packages of melanin. So what are some of the causes of differences in skin pigmentation between individuals? Well, the color of the melanin can be different. It can be more of a red-yellow, brown-black. There are lots of different colors of melanin. Melanocytes make different amounts of melanin. And also the depth at which the melanosomes are released makes a difference. So when the melanosomes are released in the deeper layers of the skin, they tend to be broken down and less of the melanin is visible from the surface. When these the melanin pigment goes further up and the melanosomes are released more superficially in the skin, then more of them are intact and visible from the surface. So the depth of the release of the melanosomes makes a difference in the skin color that is visible from the surface. But it is not, I say, not the number of melanocytes. Third link, so you know I'm serious. All right, the people with albinism still have a normal number of melanocytes, but they don't make much melanin or don't make any melanin. So that's how that works. Negative consequences of tanning. You do need some skin you need some sunlight on your skin on a daily basis to make vitamin D3, which we will talk about. But past the amount you need to make vitamin D3, now the amount you need to make vitamin D3 depends on how dark your skin is. If you have very little melanin like I do, then about 5 minutes at noon outside in summer is more than plenty. But if you have a darker skin, more melanin than I do, and it's winter and you live farther north, then you need to be outside more to get the same amount of vitamin D3. But past the amount that you need to make vitamin D3, you can burn, and UV radiation mutates the DNA and causes skin cancers. So, and too much sunlight causes wrinkles. So there's that. And orange-yellow pigment is called carotene. And it's found in yellow-orange vegetables like carrots and sweet potatoes and pumpkin. So sometimes with toddlers, you'll have a toddler who will only eat carrots or pumpkin or sweet potato mush. And then after a while, they start to turn kind of entirely orange. And that's from eating all the carotene. It eventually will start to show up in the skin. So that's why. Now, infants that aren't eating solid foods yet, like newborns turning orange, that's a different story. We'll talk about that later on in this page. So, okay. Can individuals with darker skin tones suffer some sun damage? Yes, of course. It is protective, but it's not 100% protective. So, all right, skin colors. Red is vasodilation. Vas means vessel, and to dilate means to make the diameter bigger. So vasodilation, when you make the blood vessels bigger in diameter, that allows more blood closer to the surface of the skin, and the skin reddens. So oxygenated red blood contributes to skin color. White is vasoconstriction. Vas means vessel. Constriction is when you make the diameter smaller. So when all the blood vessels on the surface of your skin constrict, then your skin will pale, like if you're scared or really cold. I know it doesn't get that cold here, but that's how that works. Oh, if you blush, this is what's happening. It's vasodilation on the cheeks, the embarrassed blush. That's what that is. It's vasodilation. Blue is oxygen-starved skin. It first shows up around the lips and in the fingernails. If your fingernails are painted, then you are missing out on a lot of diagnostic material. Actually, the viewing the nails and the color under the nails is about as much diagnostic information as you can get without cutting open the skin or like taking x-rays or something, except for looking at the retina. So like dilating the eyes and looking at the retina, you can get a lot of diagnostic information. So, all right, so blue, oxygen-starved skin, lips, fingernails. Hemoglobin. Hemoglobin is in the red blood cells. When it has oxygen bound to it, it's bright red. When it does not have oxygen bound to it, it is dark red. And so that contributes to the difference in color. And cyanosis is the blue color. So it is caused by extreme cold, like you don't find here. Cardiovascular problems, so if your heart is not pumping enough oxygenated blood around, then you can get the cyanosis, which shows up first around your lips and your fingernails or toenails. And respiratory problems, where the lungs aren't getting oxygen into the blood, whether the heart is pumping it or not. Okay, so cyanosis, extreme cold, cardiovascular problems, respiratory problems. And we'll go ahead and finish the skin color bit on the top of the next page. Jaundice is the yellow in the skin and yellow in the whites of the eyes. This is seen in liver disease, like cirrhosis of the liver, hepatitis. It is also seen in newborns because it's part of the breakdown of the blood, and newborns are born with lots of blood. They need it, but a lot of it's broken down. And so if your newborn starts to turn yellowish, orangish in the first couple of days, then you put them, you know that spot on the bed where the sunlight hits it and the cat likes to hang out? Okay, kick the cat out of the room and put the naked baby there with a diaper on, or they will pee on everything. As you know, babies wait until you take the diaper off to pee. So, true story, true story. So you put them in that spot of sunlight on the bed, not outside because, of course, you don't want baby to get a sunburn. Inside, on the bed, and the sunlight helps process the colors from the blood cells being processed. We'll talk more about this next semester when we've got terms to use for that. Yeah. And if a couple hours of that doesn't take care of it, you call your midwife, and your midwife comes to your house and she looks at your precious newborn and she says, it's not too bad. I think put them in the sun again tomorrow and they should probably be fine. If not, call me. Or no, they should have cleared up by now. Let's take them to the hospital, and they have kind of industrial UV lights, and they put the naked baby in a diaper with the eyeglasses on to protect their little eye peeps, and that UV light will help their little bodies process those colors to get rid of the jaundice. So that's how that works. And MSH is melanocyte stimulating hormone. We'll talk about it more next semester, but it does stimulate the melanocytes to make melanin. There are a few diseases that activate the MSH and will give you kind of a bronzy, dark tan kind of a look. And Addison's disease increases ACTH, which is another hormone, which acts kind of similarly to MSH and gives kind of a bronzy look. And vitiligo is the one where you do actually lose melanocytes, the cells themselves. And it leaves white patches on normal colored skin, normal color being anything not with vitiligo or albinism. And that affects about 1% of the population. So, all right, and one more thing you need to know are the ABCDEs of skin cancer. You can put these here on the top of page 18. I have them written on the bottom of page 17, wherever they fit for you. Make sure you get them down. So A is asymmetry. If you have it's called a nevus, a mole, that is asymmetric, it's not perfectly round, then you have your doctor check it. If the border is not regular, see like how this border is kind of weird, and that's obviously bad, okay? You have your doctor check it. If it has two different colors or if it changes colors, have your doctor check it. And if the diameter grows or if the diameter is ever larger than the diameter of a pencil eraser, what is that, like 7 millimeters or something, then you have your doctor check it. And the E has been added since I made this slide. E is evolving. So if it changes, have your doctor check it. And then these are some of the more common cancers. And we've got the basal cell cancer, carcinoma. Carcinoma is cancer. So basal cell will be in the stratum basale or stratum germinativum. Squamous cell carcinoma, those would be the flat cells on the top. And then malignant melanoma will be in the melanocytes. So those are all terms you know now. Excellent. So this has been ANP 1, Lecture Test 2, Video 11, and we did page 17, and we sort of started page 18 just enough to finish the skin colors. So thank you as always for tuning in. We are assuming this is going to record, so fingers crossed. And the education must go on. Dr. J out.